All right, so we've learned a lot of different reactions, but there's a lot of overlap. A lot of the mechanisms are extremely similar, if not the same. And a lot of the reactions that the compounds can undergo are also very similar. So for example, right, the acid chloride is really going to be the most useful compound because it's the most reactive. And an acid chloride can be turned into practically any other compound that we want it to be. So for example, if you add a carboxylic acid with some base, we can get our acid anhydride. We can add some alcohol to that or just straight to the acid chloride to end up with the ester. And then add some amines to end up with the amides. And of course, we can go through to any of these derivatives straight from the acid chloride. From the amide, we can also go to the nitrile. So that's a pretty cool trick there too. So in general, right, if you start off with the acid chloride, you can make anything pretty simply and pretty easily. If you don't start off with the acid chloride in most of the syntheses, it's the first step is going to be to get to the acid chloride, right? So remember, we're going from left to right, we get more reactive. And so the kind of key compound here is going to be our carboxylic acid, which has a similar reactivity to the ester. We can form the carboxylic acid pretty easily from any of these three. All we have to do is just add some acidic water. So some H3O plus, pretty easy there. From the acid anhydride, you don't even need acidic water. You can just use regular water. And then the cool thing about this acid chloride is that we can go from this from this carboxylic acid to the acid chloride with some SOCl2, right? So you can see in most of the synthesis steps, it's going to be get to the acid chloride. And the way that you get to the acid chloride is first go through the carboxylic acid. Of course, we can go from the acid chloride to the carboxylic acid as well. So really the acid chloride and the carboxylic acid are the stars of the show. The reason that the acid chloride is kind of the star of the show is because, first of all, we can turn it into any other of our derivatives relatively easily, right? It's the most reactive one. We can also turn it into an aldehyde if we want, or just an alcohol. Or if we want to attach more things, we can turn it into an alcohol with some carbon-carbon bonds, right? Using a Grignard reaction. Or if we want it to end up with a ketone, we could also do that as well. I won't fill in the blanks here. That'll be up to you, right? So we've learned a lot of reactions, but again, there's not really that many things that are new. There's a lot of overlap here. And so my suggestion, first step, I would create your own reaction map. And you'll see one in the work along. After you've created it, then you can use it on practice problems. And then once you've done enough practice problems, you won't need it. As always, the key to success in this class is just to do some practice, practice, practice.